fifth graders. So we are back with our next week of learning. I've got 2 math lessons I'm going to teach you this week that I need you to do the independent work on and to return to school. So we will finish module 6 this week, and then we will begin a new module when we come back from break. So you will have a packet at school that will need to be picked up, so that way you'll have it when we come back from break, but you won't do any of the work in the packet until after break. Okay, so we are on module 6, lesson 3, which begins on page 137. It's represent subtraction with different sized parts. So you'll be able to represent the difference between fractions with different sized parts using a visual model. Mark and his friends are putting on a play. Mark is in charge of the costumes. He measures each sleeve in one costume to be 3/4 yards long. Each sleeve should be 1/2 yard long. By how much should each sleeve be shortened? Draw a visual model to represent how much each sleeve should be shortened. So the costume sleeve, here's our hole, it's 3/4 yard long. So I'm going to break up my bar model, and I'm going to represent, here is my 3/4. So that's how long the sleeve is, and it's too long. It should be, I'm going to make a bar model the same length. It should be 1/2 yard long. So I'm going to break it in half. So if I shade this in, I can see from my picture that it is 1/4 of a yard too long, right? Because 2 of these fourths is the same as 1/2, which means 1/4, it's going to be 1/4 too long. So the sleeve needs to be shortened by 1/4 yard. So essentially 3/4 minus 1/2, we would regroup our 1/2 into 2/4 because we can see that it's the same. So 3/4 minus 2/4 equals 1/4. So each sleeve should be shortened 1/4 yard. Okay. Next page. Anderson and Joanne sold tickets for the play. Anderson sold 3/4 of the roll of tickets, and Joanne sold 1/6 of the roll of tickets. What is the difference between the fractions of the roll of tickets that Anderson and Joanne sold? So what this dashed line is the difference between 3/4 minus 1/6, right? This dashed line is this unknown part, right? It's this part that we don't know. That's what the dashed line is. So looking at the picture, who sold more tickets? Anderson did, right? And we can do that because we can see the picture it shows, right? We can see that because the visual model shows he sold more. So we're going to use the fraction model in part A to draw fraction strips in the dashed box to solve the problem. So we need to figure out what size fraction strips we probably need to draw. Well, if I look at my model, if I draw a line here, this shows to me, and I draw a line here, that 1/6 is the same as 2 parts of this, right? So if I were to break this up into 3 pieces, and I were to come all the way across, and if I were to continue on, I would have to do another 3, right? So that would mean I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 twelfths. So in this case, to find something that they have in common, my 4 and my 6 have a 12 in common. So these would be twelfths. So they would be 1/12 yard, or 1/12 of the roll. So the difference between the fractions of the roll of tickets that Anderson and Joanne sold, well, he's got 3/4, which is the same as 1, 2, 3, 4, 5, 6, 7, 8, 9 twelfths minus 2 twelfths. 9 twelfths minus 2 twelfths is 7 twelfths. So Anderson sold 7 twelfths of a roll of tickets more than Joanne. Oh, sorry. Can't see that. 9 twelfths minus 2 twelfths equals 7 twelfths of a roll of tickets more. So we're finding a common denominator. All right, number 2. 2 boxes have the same number of play programs. On the first night of the play, Diana handed out 2/3 of a box. On the second night, she handed out 5/12 of the other box. On which night did Diana hand out more programs? How much more of a fractional part of the box did she hand out? So, on the first night, she handed out 2/3 of a box. Second night, she handed out 5/12 of the other box, of a different box. So, she has 2 boxes. One box is broken up into thirds. One box is broken up into twelfths. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So, the first night, she handed out 2/3 of the box. So we're going to shade in 2 pieces. The second night, she handed out 5/12. So we're going to hand out 5 pieces. Okay? So, what night did she hand out more programs? Well, on the first night, right? Because we can visually see that 2/3 is greater than 5/12. We know because we could see it visually, right? So I'm not going to write a sentence for that part. How much more of a fractional part of the box did she hand out? So we can change our denominator on the 2/3 to be twelfths. So we need to multiply the top and the bottom by the same number, but that's going to give us twelfths on the bottom. So if I multiply 3 times 4, doesn't that give me 12? So if I multiply the bottom by 4, I have to multiply the top by 4. So 2 times 4 is 8. 3 times 4 is 12. So 2/3 is the same as 8/12. So we want to know the difference, how much more. So 8/12 minus 5/12 equals, well, 8 minus 5 is 3. So 3/12. So 3/12 is what? How much more she handed out. So the goal is to find a common denominator in some way, shape, or form. Either a number that your denominator has in common, like the 4 and the 6 had a 12 in common, or if one fraction already has a number that is in common with the other fraction, then you can multiply the top and the bottom to get the same denominator. Maria is in charge of the scenery for the play. She paints 11/12 of a board green or blue. If she paints 1/2 of the whole board blue, how much of the board that she paints is green? So her board, she's going to paint half blue. And she paints only 11/12 of the board. So that tells me if my board is 12/12, that means this much is blue, which is how many 12ths? 1, 2, 3, 4, 5, 6 12ths equals blue. And she paints 11/12, so that means 1, 2, 3, 4, 5 12ths is green. And then 1/12 of it is not painted at all. Okay? Number 2. Greta and Tran have the lead roles in the play. Greta is on stage for 3/4 of the play. Tran is on stage for 2/3 of the play. What is the difference between the fractions of the play that Greta and Tran each spend on stage? Draw a visual model to represent the difference. So we know that if I've got 3/4, so out of my whole, if I break this up into fourths, 3/4 looks like that. And then for 2/3, I've got the same length. There's the whole. But this is broken up into thirds. This is a harder model to see, but 3/4 is greater than 2/3. How will I know that? Well, let's look at my 4 and my 3. I need to find a common denominator. In this case, I can't multiply 1 to get to the other denominator. So this time I'm going to multiply the two denominators together. So if I do 3/4 times 3/3, I will get 9/12. And if I multiply 2/3 by 4/4, I'm going to get 8/12. So I can see that 3/4 is 1/12 more than 2/3. So what is the difference between the fractions? 9/12 minus 8/12 is 1/12 of the play. Oops. All right, next one. I'm not going to draw a picture for these. We're going to just do the math. We're going to rewrite the denominator. So I have 11/12 minus 2/3. I need to rewrite this one. I need to change this fraction to find a common denominator. I need to find an equivalent fraction that I can subtract. Well, I know that to get my 3 to my 12, I'm going to multiply by 4. So if I multiply 2/3 times 4/4, remember I have to multiply the top and the bottom the same. 2 times 4 is 8. 3 times 4 is 12. So now I can subtract. 11/12 minus 8/12 equals, what's 11 minus 8? That would be 3. So 3/12 is my answer. So over here, I notice that my 5, right, is what I have common with my 10. So I'm going to change my 3/5. I'm going to take 3/5 and I'm going to multiply it by 2/2. So that's going to equal 6/10. 6/10 minus 3/10 equals 3/10. And this one, I can see that my 4, I can rewrite this fraction so that way I can subtract them. So 1/4, I know my 4 has something in common with my 8. I can multiply it by 2/2. So that equals 2/8. 9/8 minus 2/8 equals 7/8. 7/8. 7/8 minus 2/8 equals 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 7/8. 7/8 And our last question for this module, or for this lesson. Hannah prints t-shirts for everyone working on the play. Her printing machine uses 1/2 milliliter of ink for each shirt. The front of each shirt uses 2/5 milliliter of ink. For how much ink does the printer use for the back of each shirt? So we want to figure out what is 1/2, right, minus 2/5. Because our printing machine uses 1/2 milliliter of ink for the shirts, front and back, and just the front uses 2/5. So I'm going to have to change both of these because I can't find a common denominator between the two. So I'm going to have 1/2 times 5/5. So that equals 5/10. So I'm going to have 5/10 minus, and then I'll have 2/5 times 2/2, which equals 4/10. 5/10 minus 4/10 equals 1/10 milliliter. So I want you to complete the independent work for module 6, lesson 3, so 6.3. You are going to complete the front and the back, and then you are to return it to me at school as soon as possible so that I can grade it. And I will get ready to record your next lesson, so you'll have 2 lessons to do this week. All right, thank you.